A scientist threw away his life's work in frustration. That discarded failure would accidentally create an industry worth over $100 billion today. This is the story of how a mistake no one wanted became something the entire world couldn't live without. New York, 1938. The world stands on the edge of war. In laboratories across America, chemists race against time, searching for materials that could give their nation an advantage in the conflict everyone knows is coming. Rubber supplies are vulnerable, dependent on plantations in Southeast Asia that could fall to enemy hands at any moment. The military needs alternatives. They need something synthetic, something they can control, something that won't leave them helpless if supply lines are cut. The pressure is immense. Every failed experiment feels like a step closer to disaster. Roy Plunkett is just 27 years old, a fresh PhD from Ohio State working at the DuPont Research Facility in Deepwater, New Jersey. He's been assigned to develop a new refrigerant, something to replace the sulfur dioxide and ammonia that leak from cooling systems and poison the air people breathe. It's unglamorous work, the kind of project that doesn't make headlines, but it matters. Plunkett is meticulous, careful, the type of researcher who follows protocols and documents everything. On April 6, 1938, he arrives at the lab before dawn like he always does. He has no idea this will be the day that changes everything. Plunkett has been working with tetrafluoroethylene, a gas he stores in pressurized cylinders. The plan for today is simple. Release the gas, expose it to specific conditions, see what happens. It's the kind of experiment he's run dozens of times before. But when he opens the valve on the cylinder that morning, nothing comes out. No gas, no hiss of pressure. Nothing. He checks the gauge. The cylinder should be full. The weight confirms it. There's something inside. He shakes it. He can hear something moving, something solid rattling around in there. This makes no sense. Most scientists would have simply requisitioned a new cylinder and moved on. The project has deadlines. The military is waiting. But Plunkett's curiosity won't let him walk away from the mystery. He does something that seems crazy at the time. He takes a hacksaw and cuts the cylinder open. Inside, he finds a white, waxy substance coating the walls. The gas has somehow transformed into a solid. This isn't supposed to be possible. Not under these conditions, not at room temperature, not without any catalyst or external energy source. Plunkett scrapes out the mysterious white powder and begins testing it. What he discovers defies everything he knows about chemistry. The substance is completely inert. Acids don't touch it. Bases can't break it down. Heat doesn't melt it until temperatures that would destroy almost anything else. It's the most slippery material anyone has ever encountered. Nothing sticks to it. Nothing. It's also one of the strongest plastics ever created, resistant to corrosion, weather, and time itself. But here's the problem. It has absolutely nothing to do with refrigerants. It's useless for the project he's been assigned. It's a failure. DuPont doesn't know what to do with this strange new polymer. They patent it, sure, but patents are cheap. They call it polytetrafluoroethylene, mercifully shortened to PTFE. They file it away. The war comes and the war goes. PTFE sits on a shelf gathering dust, a solution without a problem, an answer to a question nobody is asking. The company occasionally tests it for various applications. Every time, it proves too expensive, too difficult to manufacture, too specialized. Years pass. A decade passes. The failed refrigerant experiment seems destined to be nothing more than a footnote in chemical history, a curiosity mentioned in research papers that nobody reads. Then the atomic age arrives with a flash of light over New Mexico. The Manhattan Project scientists face a crisis. They need to handle uranium hexafluoride, one of the most corrosive substances known to science. This chemical eats through metal, glass, rubber, everything. Workers are getting injured. Equipment is dissolving. Progress is threatened. Someone remembers that weird slippery polymer from DuPont, the one that nothing could touch. They request samples. They test it. Finally, after years of rejection, PTFE has found its purpose. It's the only material that can survive contact with the chemicals needed to build an atomic bomb. The military classifies PTFE immediately. For years, its existence is a secret. DuPont manufactures it under armed guard. Only people with security clearance know it exists. The company gives it a trade name that sounds friendly and non-threatening. They call it Teflon. But even as a military secret, Teflon is barely profitable. It's phenomenally expensive to produce. The process requires extreme temperatures and pressures. The equipment constantly breaks down. Each batch costs a fortune. The only reason DuPont keeps making it is because the government insists. This miracle material that resists everything is itself resisting commercialization. The breakthrough comes from France in 1954, from a man who isn't a chemist or an engineer. Marc Gregoire is a fisherman who hates how fishing line tangles on his reels. His wife Colette suggests he try that slippery coating he uses on his fishing equipment in the kitchen. Why not coat a frying pan with it? The idea seems absurd. Teflon is for nuclear facilities and aerospace applications, not cooking. But Gregoire experiments anyway. He develops a process to bond PTFE to aluminum. On Christmas Day 1954, he gives his wife the world's first non-stick frying pan. Colette Gregoire cooks an egg. It slides off the pan like magic. No butter, no oil, no scrubbing afterward. She immediately understands what her husband hasn't quite grasped yet. This isn't just convenient. This is revolutionary. She pushes him to manufacture these pans. In 1956, they found a company called Tefal. The first Teflon-coated cookware goes on sale in France. Within months, they can't keep up with demand. American companies ignore the trend at first. Non-stick cookware seems like a gimmick, a European fad that will fade. They're wrong. By the early 1960s, Tefal is selling millions of pans across Europe. American housewives hear about the miracle cookware from friends traveling abroad. They write letters demanding to know why they can't buy these products in the United States. In 1961, the Macy's department store in New York takes a chance. They import French Tefal pans and put them on display. The pans sell out in days. DuPont finally pays attention. They begin licensing Teflon to American manufacturers. The timing is perfect. The 1960s are transforming American kitchens. More women are entering the workforce. Convenience matters. Time matters. The promise of cooking without scrubbing afterward isn't trivial. It's life-changing. Sales explode. By 1968, 10 years after the first Tefal pan, Americans are buying over 3 million pieces of Teflon-coated cookware every year. The failed refrigerant experiment from 1938 has become a household phenomenon. But cookware is just the beginning. Engineers and scientists start finding applications nobody imagined. Teflon coats the heat shields on spacecraft. It protects the fuel lines and jets. It makes Gore-Tex fabric possible, allowing clothing that breathes but doesn't let water through. Medical devices use Teflon-coated components because the material doesn't react with the human body. Communications cables are insulated with it. Windshield wipers last longer with Teflon coatings. The substance that sat useless for over a decade is suddenly everywhere, solving problems in industries that didn't even exist when Plunkett first cut open that cylinder. The numbers are staggering. Today, the global non-stick cookware market alone exceeds $20 billion annually. Add in industrial applications, medical uses, aerospace, electronics, textiles, and the total economic impact of PTFE derivatives surpasses $100 billion. Over 200 million Teflon-coated pans are manufactured every year. The material touches nearly every aspect of modern life. Your phone probably contains components coated with PTFE derivatives. The car you drive uses it in dozens of ways. The clothes you wear might include fabrics made possible by this chemistry. Think about that trajectory for a moment. A young scientist trying to make better refrigerant accidentally creates a polymer that has nothing to do with his assignment. The company that employs him doesn't want it. Nobody can figure out what to do with it. It costs too much to make. It sits unused for over 15 years. When it finally finds an application, it's for building weapons of mass destruction, kept secret from the world. Then a French fisherman's wife suggests coating a pan with it, and suddenly this unwanted industrial byproduct becomes something millions of people use every single morning to cook breakfast. Roy Plunkett never made a fortune from his discovery. He was a salaried employee. His contract gave all rights to DuPont. He received a small bonus when PTFE was patented. Years later, the company gave him a modest award for his contribution. He spent his career doing solid, unremarkable research, the kind of work that keeps laboratories running but doesn't make headlines. He died in 1994 at the age of 83, having witnessed his accidental discovery transform from worthless curiosity to indispensable material. In interviews near the end of his life, he always maintained the same humble perspective. He was just trying to solve a problem. The discovery itself was pure luck. He was simply paying attention when something unexpected happened. That's the real lesson here. The greatest innovations often come from accidents, from failures, from experiments that don't work the way they're supposed to. Plunkett could have thrown away that cylinder without opening it. He could have dismissed the white powder as contamination and ordered a fresh batch of gas. He could have ignored something that didn't fit his research goals, but he didn't. He was curious enough to investigate, careful enough to document what he found, and honest enough to report results that seemed useless at the time. That curiosity, that attention to the unexpected, that willingness to explore dead ends is what separates discoveries that change the world from laboratory waste that gets thrown away. We live in an age that celebrates overnight successes and instant breakthroughs. We want our innovations to arrive fully formed, their value obvious, their applications clear. But that's not how progress actually works. PTFE needed 16 years to find its first real use. It needed another 13 years after that to reach consumers. Almost 3 decades passed between discovery and widespread adoption. Patience, persistence, and the willingness to keep looking for answers even when the first 100 attempts fail. That's what builds billion-dollar industries from discarded experiments. The next time you cook an egg that slides perfectly off a pan, remember that convenience exists because a frustrated young chemist cut open a broken cylinder in 1938 instead of throwing it away. Remember that the material making your life easier was once considered a failure, a waste of time, a mistake. Remember that someone had to see potential in something the entire world dismissed as worthless. That's how the future gets built, not from grand plans and perfect execution, but from curious people paying attention when accidents happen and asking what if instead of walking away. If this story of how a mistake changed the world made you think differently about failure, hit that like button and subscribe for more true stories of tiny moments that transformed everything. The next video might just change how you see the ordinary objects around you.